Good afternoon, everyone.
I am Bianca Marie Dimperio.
I am Dimple Jane Impal.
And I am Joy Dimple V. Lambaco, and we are the reporters for this afternoon.
Chapter 7, Computer-Assisted Audit Tools and Techniques. First, we have to find out what is Computer-Assisted Audit Techniques. CATS is a tool that auditors use that facilitates them to make search from the irregularities from the given data. With the help of this tool, the internal accounting department of any firm will be able to provide more analytical results. With the help of the computer-assisted audit techniques, more forensic accounting with more analysis can be done. The CAT tool supports the forensic accounting in which larger amount can be diverted to the analytical form, and it also prompts for the tool detects the fraud. This tool simplifies the data and in the automated form. It's really a helpful tool that helps the firm auditor to work in an efficient and productive manner. Under the computer-assisted audit tools and techniques, we have application controls. Application controls are program procedures designed to deal with potential exposures that threaten specific applications such as payroll, purchases, and cash disbursement systems. Now, there are three broad categories of application controls. We have the input controls, processing controls, and output controls. But first, let's discuss about input controls. Input controls at this stage are designed to ensure that these transactions are valid, accurate, and complete. Data input procedures can either source document triggered or direct input. Now, there are classes of input control. We have source document controls, data coding controls, batch controls, validation controls, input error correction, and generalized data input system. For source document controls, careful control must be exercised over physical source documents in systems that use them to initiate transactions. Source document fraud can be used to remove assets from the organizations. Its controls are use pre-numbered source documents, use source documents in sequence, and periodically audit source documents. Now for data coding controls are checks on the integrity of data codes used in the processing. A customer's account number, an inventory item number, and a chart of accounts number are all examples of data codes. There are three types of errors that can corrupt data codes and cause processing errors. We have transcription errors, single transposition errors, and multiple transposition errors. Now for batch controls, they are an effective method of managing high volumes of transaction data through a system. The objective of batch control is to reconcile output produced by the system with the input originally entered into the system. Next is the validation controls. Input validation controls are intended to detect errors in transaction data before the data are processed. Validation procedures are most effective when they are performed as close to the source of the transaction as possible. For input error correction, when errors are detected in a batch, they must be corrected and the records are submitted for reprocessing. This must be a controlled process to ensure that errors are dealt with completely and correctly. There are three common error handling techniques. First is correct immediately, then create an error file, and lastly would be reject the entire batch. For generalized data input system, this technique includes centralized procedures to manage the data input for all the organization's transactions processing system. The advantages of using GDIS are it improves control by having one common system perform all data validation, ensures that each IS application applies a consistent standard for data validation, and improves system development efficiency. After input controls, we then proceed to processing controls. After processing through the data input stage, transactions enter the processing stage of the system. There are three categories of processing control. We have run-to-run controls, operator intervention controls, and audit trail controls. For run-to-run controls, use batch figures to monitor the batch as it moves from one programmed procedure to another. Specific uses of run-to-run control figures are recalculate control totals, transaction codes, and sequence checks. For operator intervention controls, it initiates certain actions such as entering control totals for a batch of records, providing parameter values for logical operations, and activating a program from a different point when re-entering semi-processed error records. Operator intervention increases the potential for human error. Next is the audit trail controls. Every transaction must be traceable through each stage of processing, from its economic source to its representation in financial statements. In an automated environment, the audit trail can become fragmented and difficult to follow. It thus becomes critical that each major operation applied to a transaction be thoroughly documented. Now, the techniques used to preserve audit trails are transaction logs, log of automatic transactions, listing of automatic transactions, unique transaction identifiers, and error listing. Now, after processing controls, we then move to output controls. Now, output controls ensure that system output is not lost, misdirected, or corrupted, and that privacy is not violated. Exposures of this sort can cause serious disruptions to operations and may result in financial losses to a firm. Next is testing computer application controls. Now, there are two general approaches for application controls. We have black box approach and the white box approach. Now, for black box approach, auditors testing with the black box approach do not rely on a detailed knowledge of the application's internal logic. Instead, they seek to understand the functional characteristics of the application by analyzing flowcharts and interviewing knowledgeable personnel in the client's organization. In this situation, the auditor tests the application by reconciling production input transactions processed by the application with the output results. The output results are analyzed to verify the application's compliance with its functional requirements. Also, the advantage of having black box approach is that the applications need not to be removed from service and tested directly. This approach is feasible for testing applications that are relatively simple. Next approach is the white box approach. The white box approach relies on an in-depth understanding of the internal logic of the application being tested. The white box approach includes several techniques for testing applications' logic directly. These techniques use small numbers of specially created test transactions to verify specific actions of an application's logic and controls. In this way, auditors are able to conduct precise tests with known variables and obtain results that they can compare against objectively calculated results. For the common types of test controls, there are authenticity test, accuracy test, completeness test, redundancy test, access test, audit trail test, and rounding error test. The next part would be computer-aided audit tools and techniques for testing controls. We have 5 CAT approaches. Test data method, which also includes base case system evaluation and tracing, and then integrated test facility and parallel simulation. For test data method, the test data method is used to establish application integrity by processing specially prepared sets of input data through production applications that are under review. The results of each test are compared to predetermined expectations to obtain an objective evaluation of the application, logic, and control effectiveness. For base case system evaluation, tests are conducted with a set of test transactions containing all possible transaction types. These are processed through repeated iterations during systems development testing until consistent and valid results are obtained. These results are the base case. When subsequent changes to the application occur during maintenance, their effects are evaluated by comparing current results with base case results. Now for tracing, the tracing procedure involves 3 steps. First is the application under review must undergo a special compilation to activate the trace option. Next is specific transactions or types of transactions are created as test data. And lastly, the test data transactions are traced through all processing stages of the program. And a listing is produced of all program instructions that were executed during the test. Next would be the Integrated Test Facility. The Integrated Test Facility or the ITF approach is an automated technique that enables the auditor to test an application's logic and controls during its normal operation. The ITF is one or more audit modules designed into the application during the system's development process. In addition, ITF databases contain dummy or test master file records integrated with legitimate records. Lastly, would be the parallel simulation. Parallel simulation requires the auditor to write a program that simulates key features or processes of the application under review. The simulated application is then used to reprocess transactions that were previously processed by the production application. The results obtained from the simulation are reconciled with the results of the original production run to establish a basis for making inferences about the quality of application processes and controls. Now that would be all for the topic Chapter 7, Computer-Assisted Audit Tools and Techniques.
So we'll proceed to Chapter 8, the data structures and CAATs for data extraction. CAATs means Computer-Assisted Audit Tools and Techniques. We will first talk about data structures. So the first kind, we have the flat file structures. It is the data processing wherein performed by standalone applications rather than integrated systems. So there are 4 types. We have first a sequential structure. It is the application that starts at the beginning of the file and processes each record in sequence. So an example of this is in order for the data 1876 to be retrieved, the user must first read their data 1874 and 1875 must be in sequence. Another type, we have index structures. There exists a separate index that is itself a file of record addresses. So this is the index, and each primary key has a corresponding data that can be located in the physical disk storage device. Another type, we have the hashing structures. It employs an algorithm that converts the primary key of a record directly into storage address. So there is no need for index because each primary key can be translated into an address that can be located in the storage. So another type, we have the pointer structures. This approach stores in a field of one record the address of a related record. So an example is this. Like the data has a link to its succeeding data. Data 1 to 4 contains an address that points to data 1 to 5. Then data 1 to 5 can locate data 1 to 6 and so on and so forth. So another type, we have hierarchical and network database structures. They are designed to support flat file systems already in place while allowing the organization to move to new levels of data integration. So another type, we have relational database structure. It is based on indexed sequential file structure, inverted list, which allows even more flexible access to data. So these are the concepts of relational database structure. The entity, it is the organization that wishes to capture the data. Occurrence, these are the number of instances. Attributes, they are the elements. Association, it is the labeled line connecting two entities. Cardinality, this is the degree of the association. For better understanding, we will have an example. So first example is every salesperson will be given one company car. So if an employee is a salesperson, he will have one company car. If an employee isn't a salesperson, he will have no company car. On the POV of the company car, it will be given to one and only employee, which is a salesperson. Another example, every manager will be given one laptop. If the money and the POV of the laptop, the laptop will be given to one manager. So it cannot be that the laptop will be owned by two managers, and it cannot be that the manager will have two laptops. So now we will talk about the anomalies, structural dependencies, and data normalization. So these are the database anomalies. First, the update anomaly. It resulted from data redundancy in an unnormalized table. Insertion anomaly. It is when the vendor cannot be added to the table. Deletion anomaly. It is an intentional deletion of data from a table. So this is an example of a normalized database table. As you can see, there are redundant data. So to be free from those anomalies, tables must be normalized. So you must consider two conditions. All non-key attributes in the table are dependent on the primary key, and all non-key attributes are independent from other non-key attributes. So this is what normalized database tables look like. These are the primary keys. These are the items in the inventory, and as you can see, from this you can trace its supplier from the supplier table, and from the supplier table you can trace the information of each supplier to the another table. That's its name, address, and telephone number. So what is the connection between the auditors and data normalization? Of course, auditors are not responsible for normalizing an organization's databases. It could be a management, or their technician, or the programmers that does it. But auditors need to know how the data are structured before they can extract data from tables to perform audit procedures.
So hi everyone. So this is the continuation for the chapter 8. So let us now move on to the next topic, which is designing relational databases. Database design is a component of a much larger system development process that involves extensive analysis of user needs, which is also the topic of chapter 5. Thus, our starting point is one that normally follows considerable preliminary work that has identified in detail the key elements of the system under development. With this backdrop, the focus will be on the following 6 phases, or also known as view modeling. So let us discuss it one by one. So the first one is identify entities. View modeling begins by identifying the primary entities of the business function in question. So to demonstrate entity identification, we will analyze the following key features of a simplified purchasing system. So the first one is the purchasing agent reviews the inventory status report for items that need to be reordered. So this is an example of inventory status report. The second one is the agent selects a supplier and prepares an online purchase order. Then the next one is the agent prints a copy of the purchase order and sends it to the supplier. So this is the example of purchase order, this one. Then lastly, after sending it to the supplier ships inventory to the company. Then upon its arrival, the receiving clerk inspects the inventory and prepares an online receiving. So this one, the receiving report. A number of candidate entities can be identified in the previous description. These are purchasing agent, receiving clerk, inventory, supplier, inventory status report, purchase order, and receiving report. But not all of these candidates are true entities that need to be modeled in the database. So to pass as valid entities, 2 conditions need to be met. Condition 1, an entity must consist of 2 or more occurrences. Condition 2, an entity must contribute at least one attribute that is not provided through other entities. So we need to test this condition for each candidate to eliminate any false entities. Among all the candidate entities, there are 3 that are not included in the database model. These are purchasing agent, receiving clerk, and inventory status report. So for purchasing agent, we have no information on this point in our brief description of the system. So we will assume no agent-specific data are captured. Hence, the purchasing agent candidate is not an entity to be modeled. And same applies to the receiving clerk. And for the inventory status report, although it contains multiple occurrences, it is still not an entity since it does not satisfy condition 2. So only inventory, supplier, purchase order, and receiving report are the true entity of the database. Is to construct a data model showing entity associations. It is to determine the associations between entities and document them with an ER diagram. So for example, the normal association between a customer entity and a sales order entity is 1 is to many, or 1 is to 0 is to many. This signifies that one customer may place many orders during a sales period. The association would never be 1 is to 1. Why? Because this would mean that the organization restricts each customer to a single sale, which is illogical. The next step in the process is to assign primary keys to the entities in the model. The analyst should select a primary key that logically defines the non-key attributes and uniquely identifies each occurrence in the entity. Sometimes this can be accomplished using a simple sequential code such as invoice number, check number, or purchase order number. Sequential codes, however, are not always efficient or effective keys. Add attributes. Every attribute in an entity should appear directly or indirectly in one or more user views. Entity attributes are therefore originally derived and modeled from user views. So in other words, if stored data are not used in a document, report, or calculation that is reported in some way, then it serves no purpose and should not be part of the database. So the attribute assigned to each entity in this figure are derived from the user views of the purchase order and receiving report and from the inventory status report that we previously normalized. The fourth step is to normalize the data model and add foreign keys. The normalization issues that needed resolution are outlined in the following section. The first one is repeating group data in purchase order. For this one, the attributes part number, description, order, quantity, and unit cost are repeating group data. To resolve this repeating group data were removed to a new PO item detail entity. So the second one is repeating group data in receiving report. The attributes part number, quantity received, and condition code are repeating groups in the receiving report entity and were removed to a new entity called rec report and item detail. And lastly, transitive dependency. This redundancy occurs because of transitive dependency in the purchase order and receiving report entities and are dropped. The next step is to construct the physical database. In this step, it is to create the physical tables and populate them with data. This is an involved step that must be carefully planned and executed and may take many months in a large installation. Programs will need to be written to transfer organization data currently stored in flat files or legacy databases to the new relational tables. Data currently stored on paper document may need to be entered into the database tables manually. Once this is done, physical user views can be produced. And for the last step is to prepare the user views. The query function of a relational DBMS allows the system designer to easily create user views from tables. The designer simply tells the DBMS which tables to use, their primary and foreign keys and the attributes. From this visual representation, the DBMS generates the SQL commands for the query to produce the view. Embedded Audit Module. The objective of the Embedded Audit Module, or EAM, also known as continuous auditing, is to identify important transactions while they are being processed and extract copies of them in real time. So the EAM approach has two significant disadvantages. The first pertains to operational efficiency, and the second is concerned with EAM integrity. The operational efficiency: from the user's point of view, EAMs decrease operational performance. While verifying EAM integrity, this approach may not be viable audit technique in environments with a high level of program maintenance. Generalized audit software is the most widely used CAATT for IS auditing. GAS allows auditors to access electronically coded data files and perform various operations on their contents. The widespread popularity of GAS is due to four factors. GAS languages are easy to use and require little computer background on the part of the auditor. Second, many GAS products can be used on both mainframe of PC systems. 3. Auditors can perform their tests independent of the client's computer service and staff. And lastly, GAS can be used to audit the data stored in most file structures and formats. So the recent version of GAS today is ACL, or Audit Command Language, which in the later chapter this will be demonstrated.